For most of human history, aging was accepted as inevitable, irreversible, and largely unchangeable. But as our understanding of human biology has deepened, particularly over the past 2 decades, the narrative around aging has started to shift from passive acceptance to active intervention. Today, a growing field of anti-aging medicine aims not just to extend lifespan, but to preserve function, resilience, and vitality well into the later decades of life. While much attention is focused on advanced therapies, like senolytics, gene editing, or stem cell treatments, a quieter revolution is taking place within nutritional science, where evidence continues to accumulate around the profound influence of targeted nutrients on the biology of aging. At the heart of this movement is vitamin D. Anti-aging medicine has often been associated with cutting-edge technology and expensive pharmaceuticals. However, aging at the cellular level, marked by inflammation, oxidative stress, mitochondrial decline, and genomic instability, is heavily influenced by nutrition. The nutrients we consume, or fail to consume, affect the delicate balance between repair and decay. And while no single compound is a magic bullet, certain nutrients like vitamin D have emerged as central players in the orchestration of long-term health. Vitamin D is classically known for its role in bone health and calcium metabolism, but its impact goes far beyond the skeleton. It acts more like a hormonal regulator, influencing hundreds of genes involved in immune function, cellular differentiation, inflammation control, and DNA repair. These are not side processes in the body. They're core systems that determine how fast or slowly we age. Emerging research suggests that vitamin D may help slow biological aging by preserving telomere length, supporting immune surveillance, and reducing chronic, low-grade inflammation, often referred to as inflammaging. In aging populations, deficiency in vitamin D is common, often due to reduced sun exposure, impaired skin synthesis, and decreased renal conversion. This deficiency correlates with accelerated markers of aging, from frailty to cognitive decline. It's no wonder that more researchers are looking at vitamin D not just as a vitamin, but as a cornerstone in anti-aging nutritional strategies. But vitamin D is just one part of the broader rethinking of anti-aging through nutrition. The future of longevity medicine will likely be built on synergies, pairing key nutrients with lifestyle interventions, using diagnostics like telomere testing or epigenetic clocks to tailor interventions, and embracing the idea that aging is modifiable, if not curable, at least slowable. Nutritional science contributes to this vision by grounding anti-aging strategies in accessible, safe, and cost-effective interventions. While pharmaceutical anti-aging research remains experimental and high-risk, nutrients like vitamin D, omega-3s, magnesium, polyphenol, and B vitamins are widely available and often low-cost. Their effects are subtle but systemic, enhancing mitochondrial efficiency, quenching oxidative radicals, regulating inflammatory cytokines, and supporting neuroprotection. In this way, we begin to see a paradigm shift. Anti-aging medicine isn't only about futuristic drugs or biohacking. It's about returning to the foundational inputs of biology: what we eat, what we absorb, and how our cells interpret those signals. The future may look something like this. A 65-year-old receives a biological age assessment based on telomere length, epigenetic markers, and inflammatory profiles. The results reveal early signs of immune senescence and mild oxidative stress. Instead of turning immediately to pharmacological interventions, the patient is given a personalized nutritional protocol, one that includes 2,000 IU of vitamin D3 daily, magnesium for improved absorption and metabolic synergy, a Mediterranean-style diet to enhance antioxidant intake, and tailored exercise and sleep schedules. Over time, retesting shows stabilization of telomere length and reduced inflammatory markers, concrete signs that aging is being slowed at the cellular level. This is precision nutrition for longevity, and it's already beginning to take shape. It reflects a more integrative vision of medicine, one that respects the power of targeted nutrients while recognizing that aging is multifactorial and must be addressed from multiple angles. Vitamin D stands out in this movement not only because of its physiological roles, but also because of its potential to serve as a model nutrient, a common deficiency with profound systemic impact, easily corrected, measurable in the blood, and linked to real-world outcomes from mortality risk to disease burden. In this sense, rethinking anti-aging medicine starts with rethinking how we value and apply nutrition. Rather than asking whether vitamin D or other nutrients are anti-aging in a sensational sense, we can begin asking smarter questions. How does vitamin D interact with genetic aging processes like telomere shortening or epigenetic drift? Can personalized nutrient optimization slow the progression of chronic diseases associated with aging? And how can we integrate nutritional science with technology and diagnostics to create dynamic, responsive longevity protocols? These are not abstract questions. They are the foundation for a future of medicine that is preventative, personalized, and rooted in biology, not just biochemistry. In that future, vitamin D is not merely a bone supplement. It's a lever we can use to nudge the aging process in a healthier direction.